Welcome to The Explainer. Today, we are on the hunt for a ghost. A ghost in the data that made scientists question a fundamental rule about how we all forget things. It's a fascinating story about how science works. So, let me ask you something. Do you think your memory is predictable? Like, does your brain follow a strict mathematical formula when you forget, say, a password or the name of a movie you saw last year? For a very long time, the answer from psychologists seemed to be a pretty confident yes. For decades, there was this really elegant idea that our memories fade away in a surprisingly predictable pattern. It was called the power law of forgetting. And we're not talking about some vague concept here. We're talking about an actual formula. The idea was that this messy, complicated thing we call memory could be mapped out by a simple, consistent mathematical rule, a power function. What's so cool about this theory is just how neat it is. The power law says your memory doesn't just fall off a cliff one day. No, it decays along this smooth, predictable curve over time. This became like a cornerstone of memory research. It was a tidy explanation for something we all experience. But, in science, what happens when a rule that seems so perfect starts to show some cracks? What if that clean, beautiful curve wasn't actually telling the whole story? Researchers started to notice a kind of glitch in the data. And that glitch has a name, the artifactual power curve. Now, an artifact is just a sciencey word for something that isn't really there. It's a distortion, an illusion created by the way you're looking at something. In this case, it means that smooth curve might be a ghost created by the statistics themselves, not by our brains. And this wasn't just some fringe theory either. Researchers like Anderson and 20 started publishing work pointing this out. As this quote shows, they began to suspect that this beautiful power law might just be a statistical artifact created by a super common practice, averaging data. So this really sets up our central mystery, doesn't it? Is one of the most famous patterns in all of psychology for real? Is it a true insight into the human mind? Or could it just be a statistical imposter that's been fooling everyone for decades? Okay, it's time to unmask the culprit. Let's pull back the curtain and see exactly how this statistical ghost is created. And it turns out the answer is, well, it's surprisingly simple. The big twist is this. The problem wasn't necessarily with our memory, but with how we were measuring it. The culprit, the thing creating this illusion, was the simple act of taking data from lots of different people and just averaging it all together to find a single pattern. And this slide just perfectly lays out the illusion. On the left, you see what an individual person's forgetting curve often looks like. It's usually exponential, a really sharp drop right at the beginning, and then it levels out. But when you take dozens or hundreds of those unique individual curves and average them, like you see on the right, they magically smooth out into that perfect power curve. It's like taking photos of 10 totally different people, layering them on top of each other, and getting one blurry composite face that doesn't actually look like any single one of them. And that's the heart of it, right there. The very act of averaging, which is a totally standard thing to do in statistics, can actually create a new reality. It takes all these unique individual patterns and cooks them into one smooth but totally misleading group curve that might not represent how anyone actually forgets. Okay, so if averaging is the problem, what's the fix? How do scientists get around this illusion to see the real picture? Let's take a look at how they do it now. The modern approach is just beautifully logical. Instead of mushing all the raw data together right from the start, you analyze each person's data on its own first. You find the true pattern for each individual before you try to figure out what they might have in common. So they use these really sophisticated methods called hierarchical models. And you can think of it like this. First, you look at one person's data and find the best mathematical rule that describes their forgetting curve. Then, you do that for the next person and the next. Then, finally, instead of averaging the raw data points, you intelligently combine the patterns themselves to see if there's a real overarching rule. And why go through all that trouble? Well, it's because this method allows researchers to get a much more accurate picture of how memory really works. It lets them separate the actual psychology from the illusion created by the statistics. But here's the twist. Uncovering this statistical ghost didn't actually solve the mystery. Nope. In fact, it just blew the doors open on a whole new, really fascinating debate. The case is far from closed. The big question that scientists are wrestling with right now is this. Is the power law of forgetting always an illusion created by averaging? Or Could it be that for some people, or maybe for certain kinds of memories, their brain genuinely does follow a power law, even when you look at them as an individual? And this table really lays out the two sides of that debate perfectly. On one hand, you have the argument that these curves are purely artifacts. They are illusions of the group, created by our methods. But on the other hand, there's some evidence from individual data that suggests for some people it might be a real, genuine psychological process. The scientific jury is still out on this one. So you might be thinking, okay, this is an interesting scientific detective story, but why does it really matter? Well, for one, it completely challenges our basic understanding of how memory works. It's also this powerful reminder that the scientific methods you choose can literally shape the conclusions you reach. And, I think most importantly, it shows that science isn't just a book of facts, it's a living, breathing, ongoing conversation.
And that leaves us with one last really big thought to chew on. When we analyze the world through data, are we always seeing reality as it truly is? Or are we sometimes just seeing a beautiful, compelling reflection of the very tools we chose to use? It's a huge question, and it goes way beyond just the study of memory.